Hey there, let's go ahead and do a little practice of combining principles of equality. Previously I talked about using the addition principle, and I've also talked in class about multiplication and division. And what I want to do is combine all of these principles to solve multi-step equations. So basically what that means is we're going to be isolating, or our main goal continues to be to isolate the variable on one side of the equal sign. But previously what we've done is we've only gone through the sequence one time. That means use either the addition principle or multiplication division principle, and then made sure, if we did one thing to one side, we did it to the other side, and then we found our solution. But in some of these problems we're going to see, we're going to have to do one or more principles a few times before we get to the solution. And so I have just a few examples for you, and like always we'll do a lot more examples in class. Now this one is a common one that you'll see, this type of example where you have a number times a variable plus or minus another number, and then that's going to equal another number. Okay, so in this example we have 4x plus 7 equals 35, and again our goal is to figure out what x is, and then of course we can check it later. But notice here that we have a couple of operations going on. This is 4 times a number, and then also this, we are adding 7 to that amount. So now in the past we talked about order of operations, and you might have remember PEMDAS as a way to remember order of operations. And in the past we would always multiply before we would add. But when we're solving for a variable, we're actually going to do the opposite. We're going to do the add subtract first before doing the multiply or divide. Okay, so knowing that, let's go ahead and get rid of that 7 by moving it to the other side. So again, we're going to do the opposite of addition. We're going to subtract, or you can add the opposite of positive 7. You could go plus negative 7, but I'm just going to write it this way. I'm going to do the opposite of adding, both sides, and then I'm left with 4x equals 28. Now you can see that x is not by itself, and that's why we've got to go through the sequence again. In this case we have 4 times a number, so the opposite of multiplication is going to be division. We're going to divide by positive 4 both sides. That's going to get eliminated, and then we've got x, or 1x, equals 7. Now it's always a good idea to take your solution and plug it back into the original equation, just to make sure you did your math correctly. So I'm going to go ahead and do that real quick. I'm basically asking, is this going to equal this, 35? 4 times 7 is 28, plus 7, and that is indeed going to give me, 35. 35 is equal to 35. So this is a true statement. Sorry about that. This is true, and because that's true, this is the solution to this equation. Okay, let's go ahead and do a couple more examples, and I'm going to zoom out so you can see a little better. And let's do one in which we have we're going to combine before we do any solving. So for instance, if we have 3x plus 5 equals, or excuse me, 5x equals negative 16, notice we've got 2 variables. They're the same variable, and they have the same exponent. So whenever you have that situation, remember you can combine like terms. Especially you can combine like variables if they're the same variable raised to the same power as in this case. So we're just going to look at the coefficients and add those two. 3 and 5 make 8. So we've got 8x equals negative 16. Okay, now this isn't, we're not going to be doing multiple, or we're not using multiple principles to solve for x, but this is an example of doing more than just using one of the principles. You know, in this case, we are combining like terms first, then we're going to go ahead, and in this case, we're going to divide by 8, and we'll get x equals negative 2. Now, I could go ahead and plug it back in, and I'll go ahead and do that. So 3 times negative 2 plus 5 times negative 2. That should give me negative 16. We're not sure yet. That's going to give me negative 6. That's going to give me negative 10. And we've got two negatives. We're adding them together. We're going to get negative 16. And that indeed does equal negative 16. So negative 2 is the solution. All right, let's try another one. Another kind. Now, in this case, the example, we're going to have a variable on both sides of the equal sign, the same variable, but we're going to have to move some numbers around. Okay, so in this case, I'm going to have a term in which I've got a coefficient with the same variable x. I'm also going to have a constant over here too. So it doesn't matter really which way you move numbers around. The thing is that you want to move in one direction for one type of number and then the other direction for the other. So I'm going to go ahead and move this negative over here and then this negative over here. And so first I'll do the x values. So positive 3x, that's the opposite of negative 3x. So I'm going to add 3x here. And then notice I'm not eliminating it here, but I am here. So 4 plus 3 is going to give me 7x minus 2. This gets eliminated, and then I have 5. I don't have to write positive 5 there. All right, now I'm going to move this negative 2 to the other side. So to eliminate it on this side, I have to add 2, because that's the opposite of subtract. So add 2 to both sides, and I'm left with 7x equals 7. Now this problem worked out nice because clearly when we divide by 7, we're going to get 1. That's a nice, easy answer there. Okay. And if I were to plug this back into my original equation here, let's see if I can write it down here. I've got 4 times 1 minus 2 equals negative 3 times 1 plus 5. Well, that's going to give me 4 minus 2 is going to give me 2. And negative 3 plus a positive 5 is also going to give me the 2. So this is going to be a true statement. So the solution for this equation is going to be 1.